does centralized ledger control of our ATM service pose a substantial security risk? As Stan Lee taught us through Spider-Man, with great power comes great responsibility. The question that follows from that is, do you trust your bank? Do you trust them not to take arbitrary actions against you? And do you trust them to defend you from hackers? Hey everyone, this video is sampled from my online course which teaches you tokenomics for fundraising. You'll learn about the fundraising process, key tokenomic concepts, and get a complete spreadsheet model that you'll learn how to use by solving real-world fundraising problems. You can find the link to the full course in the description section below. And if you'd like to support this channel and help me to create more free content, please like, share, subscribe, and hit that notification bell. That's all. Now back to the video. Hi everyone. So today we're going to look at decentralized control and understand it as a feature that helps us to defend against arbitrary and non-consensual exploits of control. So this is the second of the lectures in this introductory course section, which is titled Blockchain 101. The key points we'll cover today are: what is centralized control and why does it matter? We'll then look at the solutions that we've used so far to protect ourselves from exploits of centralized control. We'll then look at blockchain's alternative solution to this problem, which uses distributed ledgers, permissionless data validation, and cryptographically secured consensus. We'll finish up with an examination of the value-add potential that blockchains can bring to businesses. So let's recap briefly. Last time, we saw how ledgers can be used to control business activities and used an ATM cash withdrawal request as a helpful example. That was illustrated in this simplified flowchart shown. We stressed that the ledger's state, or its data, is now central to deciding what ends up happening in this system. In that sense, the ledger is now used to control the transaction possibilities between the user and their bank. This is a serious and important role. If the ledger is wrong or its data are changed, the user may not be able to access their assets. So how do we get the data in this ledger right? Well, it needs to be controlled. But that doesn't happen by itself. So who or what then is responsible for this control? Your first answer may be to say that, well, rules control the ledger. Remember, we have this write-back process in the system that runs whenever a transaction is executed, and that's governed by rules that are typed up in code. But if we think that rules control the process, that's really just pushing the answer one step further back, because we can now ask, well, who controls those rules? Now, the simple answer in this case is to say that it's the bank. Let's take a moment then to simplify this diagram to center on the ATM service, and now to also show the users who depend on that service. So now we can see that we have thousands of users on the right and the bank there on the left. Now, even though a bank is made up of many employees, they are all hired to serve the bank's corporate interests. So that means we can meaningfully talk about the bank as a single agent. From that perspective, control of the ATM service sits in the hands of one actor, the bank. So what we're showing here is an example of a system with centralized control. Now, is that a problem? Well, not necessarily. Sometimes centralized control is good. That statement would be heretical to quite a few people in the crypto community. But let me give you another example of a case where this is likely to be true. Consider the design for a steering wheel for an ordinary car. Now, it's fairly obvious that it is better to centralize direct control of the steering wheel in the hands of a single agent. If we used a different design that required joint control for that process, we'd be creating all kinds of problems. So what about our ATM service? Would it be better for the ledger to be centrally managed and controlled by the bank, or to be jointly controlled by users in a decentralized way? Let's approach that question in the same way that we did for our steering wheel example, thinking purely in terms of the processing efficiency required of this task. Putting aside anything that you may already know about blockchain technology, your intuition probably suggests that ledger control would be better handled by one single specialized agent. But the thing is, efficiency is not the only thing we care about. We also care about how systems perform in a variety of conditions, including conditions where things go wrong. We need to think about risk. And it is from a risk perspective that we find vulnerabilities in a centralized ledger control design. In this example, the bank has custody of assets for lots of users. Given the powers of control that the bank has in the system, it also has the ability to arbitrarily change those rules to gain at the user's expense without their consent. And in our electronic age, it isn't just the bank's intentions that we need to be concerned about. The bank's digital infrastructure could be hacked into by a bad actor who then exploits the centralized control for their gain. So what does all this tell us? Well, for this ATM service, we have two competing design recommendations. If we focus on efficiency, we might choose a centralized design. But if we focus on security, we might choose a decentralized design. This distinction between risk and efficiency is subtle but substantive. Keeping it in mind will help you to appraise the benefits of decentralized design solutions with greater clarity and precision. Okay, so let's take a moment to digest all of that and restate our key insights in a more generalized way so that we're not too attached to this ATM example. First, control is the ability to intervene in a system to get a desired outcome. This control can be engineered to be available to one or to more agents. We can also engineer control to require necessary input from more than one agent. Control that only requires, admits, or is used by a small number of agents is centralized. Control designs can be evaluated for their efficiency and for their risk attributes. These are distinct and somewhat separable concerns, and sometimes they are also in tension with each other. An efficiency-optimized solution may be centralized, while a security or risk-optimized solution may be decentralized. The optimum for overall performance may require us to trade off design characteristics against each other. Centralized designs may be efficient in ideal circumstances, but have poor risk characteristics. So we are in a situation where the optimum design really depends on how you weigh up different factors. We need to ask ourselves, does centralized ledger control of our ATM service pose a substantial security risk? As Stan Lee taught us through Spider-Man, with great power comes great responsibility. The question that follows from that is, do you trust your bank? Do you trust them not to take arbitrary actions against you? And do you trust them to defend you from hackers? You may think that I'm building up to some kind of conspiratorial crescendo here, but that's not the case. For those of us who are lucky to live in a prosperous economy, the practical, everyday, and common sense answer to that question is, yes, we can trust our banks to let us take out our deposited cash, and their systems are well defended against hackers. How is that possible? Could it really be that our bank managers share the same moral strengths and virtues as Spider-Man? Of course not. It took hundreds of years and bloody contests of power and the updating of our cultural norms to end up with behaviors and institutions that keep the actions of bad actors in check. By restraining the opportunities for these exploitative and discriminating behaviors and creating threats that discourage others from trying. In addition to that, market competition also exerts its own restraining forces on business behavior. If businesses know that they will lose out revenues to a competitor when they act dishonestly, they will be motivated to stay honest to stay in business. The competitiveness of the market depends on how many businesses there are providing a given service and how easy it is to set up a new business that is able to compete with those already present in the market. So let's add these insights back into our earlier example and diagram. We can now say that while coding of the rules is in direct control of the bank acts in compliance with external rules that it follows. These include both explicit and implicit rules about proper commercial conduct. And we've just seen that these rules are generated and maintained by a complex web of institutions and influences. So how does all this inform the key question that we asked earlier? Well, it tells us that it depends. Centralized ledger control does not pose a security risk when the ledger is only used to control assets that are owned by the controlling agent, or when the centralized controllers share the same interests as the asset owners. It's also less of a problem when there is a threat of competition that keeps businesses honest, or when the economy benefits from social norms and institutions that avoid and deter adverse behaviors. Turning to the other side now, centralized control does pose a security risk when the opposite facts are true. When the ledger is used to control assets that are not owned by the controlling agent, when the centralized controllers have different interests to their users, when there is not enough market competition to create a threat that keeps businesses honest, or when social norms and institutions enable or encourage corrupt and adverse behaviors. Let's look at the right-hand side here for a minute. These clearly are not a rare or unlikely set of circumstances. And that suggests that we should take the security concerns seriously and ask, what else can we do about them? It's probably not a massive spoiler at this point to tell you that blockchains give us an alternative solution. But to explain how, we're going to have to sketch out some of the technical details of how they work. So get ready, because this is going to be quite the ride.